So the other mathematical skill that's going to be pretty fundamental to this course, and so we'll go ahead and review it right up front, is just going to be how we solve for a system of equations. So what we're going to tend to do is do that using substitution, because that's going to be the most common way that we'll solve for a system of equations within this class. So that's the way that we're going to review it. There are obviously other ways that you guys may have previously learned in terms of how to solve a system of equations with a set of unknowns. And when you find appropriate equations to use those alternative methods, certainly feel free. But we will tend to use substitution simply because in many of the equations, the way that they're going to be set up in the physics class, substitution is just going to be the most straightforward approach to take. So if I have two equations with two unknowns, like in this example here, and in this case, I want to solve for what x and y are. So what I'm going to do is I'm going to take one of my equations and solve that for one of my two unknowns. So in this case, I'll happen to take the first one and solve it for y. And there's nothing magical about making that choice. It's just that in sort of looking at this quickly, I noticed that if I solve that equation for y, the coefficients out front still come out to be rather clean. I could have solved the first equation for x. I could have taken the second equation, solved it for either x or y. It doesn't really matter. It's just in this case I've chosen to take the top equation and solve it for y, and that's left me with the expression that y is equal to 2x minus 5. So now what I'm going to do is I'm going to take that expression for y and plug it into my other equation. So I'm going to take my 2x minus 3y equals 11 equation and plug in that expression for y. So I'm going to have 2x minus 3 times 2x minus 5, that equals 11. And so the real key in terms of just making sure that I minimize my mistakes here is I just need to make sure that I follow the rules of algebra, and so go ahead and distribute that negative 3 correctly. So what I'm going to end up with is 2x, negative 3 times 2x is minus 6x, negative 3 times negative 5 is plus 15, and all that still equals 11. So at this point, it's combine my terms with x on one side, combine my terms that don't have x on the other, and so what I get is 2x minus 6x is negative 4x, and the 11, when I take the 15 over, that's 11 minus 15, that ends up being negative 4. So you'll notice that what I've done by making this substitution is I've basically created one equation with one unknown that I can go ahead and solve for, and that's what I'm doing, is solving for x. At this point, the only thing left to do is divide both sides of the equation by negative 4, and so I'm left with x equals 1. Well, once I've solved for x, I can now take it and plug it back into my expression for y. And so in this case, what I get is y equals 2x minus 5. Well, that's going to be 2 times 1 minus 5, so y happens to be negative 3. So once I've got my two answers, right, for x and y, what's an obvious thing that I can do? Well, it would be nice, having done all this work, to check and make sure that they make sense. So how can I check my answers to see whether or not I've got the correct things before I worry about handing something in or trying to act like that's the correct answer? Well, I can go back to my initial equations and plug in my values for x and y and see if that's consistent. So if I plug in x equals 1 and y equals negative 3 to both my first and second equation, do my equations work out? So with my first equation, I got negative 4x plus 2y equals negative 10. And so when I plug in x equals 1 and y equals negative 3, I get negative 4 times 1 plus 2 times negative 3, which is negative 4 plus negative 6. Sure enough, that's negative 10. So that checks out. Do the same thing with my second equation. And so I get 2x minus 3y equals 11. Plug in x equals 1, y equals negative 3, and I get 2 times 1 minus 3 times negative 3, which is 2 plus 9, and sure enough, that's 11. So again, it's easy enough for me to take my answers, plug them back into my initial equation, check, make sure that they make sense.